Hello everybody, in this video we're going to go over the Chapter 6 study guide, in particular questions number 11 through 18, so let's get right into it. Number 11, we have the instructions say, assume x and y are functions of t, evaluate the derivative of y with respect to t, or dy dt. So to get this started, we're going to first find the derivative of our function here with respect to t. D dt of, and we just rewrite the entire function, x y squared equals 4. We notice it right off the bat. This is a product rule. And so we have first times derivative of the second. And because we're doing everything with respect to t, we have to remember to always include the dy, the dx, dt terms. And then the derivative of 4 is 0. Okay. And all we need to do now is just to plug in the three values that were given at the beginning. Dx dt equals -5, x equals 4, and y equals 1. So let's plug them right in. Okay, so let's evaluate this. That's 4 times 2 times 1 equals 8. Dy dt plus 1 squared times 1 is 1 times -5 is a -5. So actually we're just going to do -5 equals 0. Take the derivative. Step 2 is to plug in our variables. And step 3 is to isolate dy dt. And so for this, we will have 8 dy dt equals 5 by adding 5 to both sides. And now we divide both sides by 8, giving us our answer of 5/8. Answer to the first problem is done. Second problem, same method as the first. We just have a natural log. So as always, step 1 is to take, step 1 is to take the derivative of the entire function. So d dt of x squared natural log of y equals 4x. Now notice we have an x on the right-hand side of the equation as well on the left, which is why we take the derivative of the entire equation, not just one side or the other. Okay, so we see here that we have another product rule. So first times derivative of the second, derivative of natural log of y is 1/y times dy dt plus the second times derivative of the first. Remember, we need the dx dt equals derivative of 4x is 4 times dx dt. Okay, step 2, plug in our known variables. So let's plug them all in. 3 squared times 1/y, which is just 1, times dy dt plus the natural log of 1 times 2 times 3 times derivative of x, which is 7 plus 4 times derivative of x is 7. And let's simplify this up. Let's clean this up. Okay, so we've got 9 dy dt plus, and we know the natural log of 1 is 0, which means this entire piece cancels out because it's all multiplied together. So we don't even need to add anything. We know this equals 4 times 7 is 28. And so dy dt equals 28 over 9. Final answer. We don't even need to worry about isolating as much because it's just simply dividing by 9. Okay, so moving on to our word problems. Number 13. The demand equation for a certain product is 4p squared plus q squared equals 1100, where p is the price per unit in dollars and q is the number of units demanded. We're looking for dp dq, so the derivative of p with respect to q. Okay, so first off, I'm going to highlight that we're looking for this dp dq, the demand equation. So this is an equation that's important for us. Okay. Price per unit in dollars, q is the number of units demanded. Okay. Alrighty, so let's find dp dq. So we're just going to take the derivative of the entire function with respect to q. Let me draw q there. Okay, derivative of 4p squared is 8p times dp dq plus, now since it's with respect to q, we don't need another dq over dq. So that's just 2q. Derivative of 1100 is 0. Okay, and that's step 1. Step 2 is simply isolating dp dq. So to isolate dp dq, you would start by subtracting the 2q to the other side, giving you negative 2q. And now we divide both sides by 8p. And simplify our fraction. Negative q over 4p is our final answer. Awesome. So moving on to number 14, the position of a particle at time t is given by s, where s equals this function. Find the velocity ds dt. So right off the bat, I want to highlight ds dt and our equation here that we're going to be working with so that we know exactly what we're going to be doing. So we notice that this problem has a lot of individual terms, so we want to write small. So let's find the derivative with respect to t of the entire function. S cubed plus 2st plus 4t cubed minus 5t equals 0. Okay, so the derivative of that is 3s squared ds dt plus, and we see we have the power rule here because we have two variables, s and t. So that's first times derivative of the second, dt over dt. I should have realized that gives us 1. First times derivative of the second, so just 1 plus the second times derivative of the first, ds dt, okay, plus 12t squared minus 5 equals 0. And now we have our derivative there. Step 2 is we're going to simplify everything down and isolate ds dt to give us our function. Okay, so I'm going to just start by rewriting 3s squared ds dt plus 2s plus, that's actually 2t ds dt plus 12t squared minus 5 equals 0. And now we subtract all the terms we don't need over to the other side that don't have ds dt. Negative 2s, subtract 12t squared plus 5. Okay, we notice now that we have two terms on our left-hand side that are just ds dt, and so we can factor them out to leave us with 3s squared plus 2t on the inside equals our right-hand side from the last step that is unchanged. And now that we have a form on the left-hand side that is two pieces multiplied, we can easily divide the entire right-hand side by the part in the parentheses to give us ds dt as desired. Five over 3s squared plus 2t. It looks like a very messy problem as the solution, but sometimes that's what we get. Okay. Moving on to number 13. Given the revenue and cost functions R and C, where X is the daily production, find the rate of change of profit with respect to time when 25 units are produced and the rate of change of production is 8 units per day. So I will start with a bit of highlighting. So right off the back, we have revenue and cost functions, which we know are going to be important, where X is the daily production, so X is our variable there. Find the rate of change of profit with respect to time. So we know right off the back that that's what we're looking for. We're looking for dP, rate of change of profit, with respect to time over dt. Right? With respect to time, when 25 units are produced, that gives us our X equals 25 units. And the rate of change of production is 8 units per day. So the rate of change of production is 8 units per day, which in short means, so what is production? Production is X, is the daily production. So this is dx dt equals 8 units per day, UPD. Okay, so we have our three pieces there. We have our revenue and cost function. We know that the profit function equals revenue minus cost. So this, we'll just start plugging stuff in. So profit equals 32x minus 0.3x squared minus 6x plus 15. Good. We will distribute the negative sign through. 32x minus 0.3, typo there, 0.3x squared minus 6x minus 15. Haven't actually done anything yet. I just distributed the negative sign. Okay, simplify that a bit more. We have 32 minus 6 is 26x minus 0.3x squared minus 15. Still haven't done anything yet, just simplifying down our function. Okay, so now we know that we need to find dp dt. So step 1 is setting up our function. Step 2 now is to find derivative with respect to time of the entire function. And so that is going to be dp dt equals derivative of 26x is 26 dx dt minus 0.3x squared turns into minus 0.6x dx dt minus 15 becomes 0. So we just won't even bother writing that. Okay. And now we simply just plug in all of our variables that we know. So dp dt, we know 26 times dx dt is 8 minus 0.6, x is 25, and dx dt again is 8, which would give us rate of change of profit is, I'll do this on my calculator, 26 times 8 $88 per day. We want to make sure we write per day. Awesome. Moving on to number 16. This problem states the length of a rectangle is increasing at a rate of 8 centimeters per second, and its width is increasing at a rate of 3 centimeters per second. When the length is 20 centimeters and the width is 10 centimeters, how fast is the area of the rectangle changing? So a lot of things to keep track of. First is length of rectangle increasing at a rate of 8 centimeters. Width is increasing at a rate of 3 centimeters. So we know length increasing 8, width increasing at a rate of 3. When the length is 20 centimeters and the width is 10 centimeters, how fast is the area of the rectangle increasing? So we want to know the rate of change of the area of the rectangle. So how fast is the area increasing? Cool. So let's put all these pieces in. So dl dt is 8, increasing. Ooh. Gotta figure out why it keeps glitching among that. dw dt is 3 centimeters per second. So when the length is 20 and the width is 10, we want to look at dA, which is area. How fast is the area increasing? So what's the rate of change of area? All right, so we need to think, well, how do we find the area of a rectangle? So the area of a rectangle is length times width. So then from there, we can go to find the derivative with respect to time of area equals length times width, which will give us dA dt equals, so this we can see is a product rule function. So first times derivative of the second plus the second times derivative of the first. In case you don't know what this swiggly cursive L is, we use that instead of just like the regular line for L, because this looks too close to a number 1. So we use the curly L so that we can differentiate the difference. That's a fun math fact. Okay, so now we have our derivative here. We're just going to step 2, plug in all of our known values. So we don't know what dA dt is, but we know what the length is. It's 20. We know what the rate of change of width is 3, plus the width, which is 10, plus or times the rate of change of the length, which is 8. So this will give us 20 times 3 is 60, plus 10 times 8 is 80, 60 plus 80 is 140. And how fast is the area of the rectangle increasing? So we know its area, centimeters squared, and it's per second, because that's what the rate of changes were above. And that's it. Moving on, number 17. So on the exam, we're going to have the volume of the sphere there. So luckily we won't have to memorize it, although it's a good formula to know. But number 17, a spherical balloon is inflated with helium at a rate of 110 pi feet cubed per minute. How fast is the balloon's radius increasing when the radius is 3 feet? So it's inflated with helium at a rate of this much. And we can see that. Ooh, it didn't work out, right? So rate, that's the key word there, of 110 pi feet cubed. Don't forget, you have to include the pi. So how fast is the balloon's radius increasing when the radius equals 3 feet? So we have 3 pieces here. We have the rate of change of volume equaling 110 pi. We're looking for the rate of change of the radius with respect to t when the radius equals 3. So let's take the derivative of the volume. So dv dt equals the right-hand side 4/3 pi. I'm just going to bring out because that is just a constant, times r cubed turns into 3r squared. Don't forget the dr dt. And so that's our step 1. And step 2 is now just to plug in all the known variables. So 110 pi goes for rate of change of volume. I see right here that the 3 on the top and the 3 on the bottom cancel out. So we just have 4 pi left over. We know the radius is 3, so that's 3 squared, not cubed. 3 squared dr dt, and now we just simplify. Isolate our dr dt. Right, so because I flipped the problem around, it's 110 pi divided by 36 pi. Pi's cancel out, and so we would get 110 divided by 36, which simplifies to 55 over 18, and we have feet per minute as our rate. Final answer for number 17. Okay, last problem here, number 18. Moving on to our final problem, number 18. A ladder is slipping down a vertical wall. If the ladder is 20 feet long and the top of it is slipping at a constant rate of 5 feet per second, how fast is the bottom of the ladder moving along the ground when the bottom is 16 feet from the wall? Okay, so let's start highlighting the pieces that are important. So first off, we see that the ladder, 20 feet long. So that's a constant length. It won't change. The top of it is slipping at a constant rate. So top is at a rate of 5 feet per second. How fast is the bottom moving? So that's another rate of change when the bottom is 16 feet from the wall. And we know that the ladder is slipping down. So these are the pieces I'm going to identify first. So the ladder is 20 feet long. I'm going to give that the value of C, 20, because if we're thinking Pythagorean theorem, the ladder is leaning on the wall, so it's the hypotenuse, slipping at a constant rate. The top of it is slipping at a constant rate of 5 feet per second. So the wall will have A. So dA dt is the rate of change. It's slipping down a vertical wall, so that's negative 5 feet per second. And they want to know how fast is the bottom of the ladder moving. So dB dt equals question mark when the bottom is 16 feet from the wall. So when B equals 16 feet. So now we have a good chunk of information here to start putting together some sort of a picture. So I'm just going to draw that picture here now. Okay, so we have the ladder, which is 20. One of the adjacent sides, 16. We don't know what A is, but we can use Pythagorean theorem in a moment to find that out. dA dt is negative 5. We know that because the ladder doesn't change its size, its rate of change is 0. And we are looking for dB dt. We don't know what that is. Okay, so first let's figure out what A is. So this is going to be using the Pythagorean theorem. So Pythagorean theorem says A squared plus B squared equals C squared. We know some of these values already. So it's 20 squared, 16 squared plus A squared. So let's just quickly solve for A. So we'll take 20 squared minus 16 squared gives us A squared equals 144, or that A gives us 12. Because the square root of 144 is 12. Okay, so now we know that A equals 12. Awesome. And now we want to find what dB dt is. So the only way to get that is to take the derivative of a function that allows us to check for related rates. So this is part 1. Part 2 now is to take the derivative, and the only function that we have is this A squared plus B squared equals C squared, Pythagorean theorem. We're just going to take the derivative of that. So taking the derivative with respect to time, of a squared plus b squared equals c squared. We had 2a dA dt plus 2b dB dt equals 2c dc dt. There we go. Okay, now let's plug in values. So we know what a is now. A is 12. 2 times 12 dA dt. We actually know what dA dt is. It's -5 plus 2 times b is 16. dB dt is what we're looking for. And then 2 times c is 2 times 20 times dc dt, which is 0, gives us a big 0. So we don't even need to bother writing any of that. Okay, so 2 times 5 times 12 equals -120. Plus 2 times 16 is 32 dB dt. And now we just isolate for dB dt. So first I'm going to add 120 to both sides. And then divide by 32, which gives me 120 divided by 32 gives me 3.75 or 15/4 feet per second. Okay. Well, folks, I hope that this video was able to help you with all of your problems, and good luck on the upcoming exam. Have a good night.